Here we go. This will be a recorded session. So as you come in, you'll hear the voice tell you. I'm also going to, where's my turn on the transcript?
Oh, I think Colleen is a
Live transcript.
List has to do it.
Okay, yeah, Colleen, is she still there? There it is. All right. So we've also turned on live transcription, which if you want to activate the closed captioning on your toolbar or turn it off, that is your choice here today. We also want to acknowledge and have everybody just kind of draw your attention really quickly to our community agreements. We share these at the beginning of every meeting of our community, of our committees or board. And our agreements are to honor group wisdom through curiosity and respect, encourage questions instead of assumptions, do our best, assume good intent until proven otherwise, acknowledge the difference between intent and impact, take space and make space for conversation, being inclusive and using language that helps us be present, asking for what you need and offering what you can so that we can uphold these commitments and lean into or learn from our discomfort. This is all to seek a community and culture that is respectful, comfortable, open, curious, and inclusive, besides being kind. So I hope that you take these things out into the world other than just here. See, these are good agreements to have everywhere. Today, we are happy to share the IBC 2021 updates and adoption into Oregon Code by Code Unlimited. So thank you for coming, and thank you to Code Unlimited for this presentation. I won't read every bit of this, but these are our learning objectives. The 2-hour presentation will be followed by a Q&A session. So please also feel free to chat your questions throughout. We'll try and capture them and make sure that the speaker has answered them all. Please remember to mute your mic during the presentation and unmute your mic during the discussion if you want to ask questions. We do suggest that you set your camera to speaker view. And as we mentioned, this presentation is being recorded. Here is the course number and all of the details that you need in case you'd like to take a screenshot. However, if you are an AIA Oregon member and you've provided your information at registration, we'll be reporting this for you. Please make sure you use your first and last name here on the recording, though, because we use that to check against our list if we need to. Here again are our learning objectives, very clearly gain an overview of the reasons for and the use of the history of code adoptions, to review core concepts and updates on occupancy classification, atriums, labs, and mass timber construction types. Learn about 2022 OSSC changes to allowable heights and areas, fire resistance, fire ratings, and fire protection systems, and learn about transitioning from 2019 to 2022 based Oregon codes as related to means of egress. There are also some upcoming Oregon events that we want to let you know about. In Bend, the City of Sisters Development Code update presentation will happen on Tuesday, November 8th from 12 to 1. We do encourage that you check that out on our events page. You can sign up for these things right from our website, www.aiaoregon.org. We also have our COAT Digital Design Series presentation coming up on November 9th from 4 to 5 p.m. With the Energy Trust, AIA Oregon, and AIA 2030 signatories. And then, of course, our November 18th Oregon Architecture Awards celebration at the Portland Art Museum. It's going to be a really fun get together. So if you have not bought your tickets, please do. We will have access to 4 floors of the contemporary art galleries next to the Mark Building, or in the Mark Building of the Portland Art Museum where we'll be. So it's going to be a bunch of fun, and we hope you'll join us. Today, we will be hearing from our speaker, Samir Mokashi. I hope I've said that right. He is the founding principal and director of Code Unlimited, and he has over 30 years of experience in regulatory requirements. He has successfully led design teams through highly demanding programs, complex designs, challenging budgets, fast-track schedules, and rigorous requirements. The advantage of having worked throughout US, Europe, Asia, and Middle East is evident in the projects, large or small, that Samir leads or consults on. He has been involved in codes development at local and national and authored several code alternatives and variances that resolved multidisciplinary issues simply and effectively. He has a unique ability to deliver simple and elegant solutions to problems that stump most others. The depth of his knowledge and strong communication skills have earned him wide respect from city and state officials, as well as designers, developers, and architects. He is a sought-after speaker, accredited educator, and highly valued mentor to young professionals. So we are very excited and happy to turn over our presentation today to Samir, and welcome. Thank you very much for your time and being here with us today.
So thank you very much for AI Oregon, and I will be joined by Jody Orison from the city of Portland as well. And the structure of today's presentation is I will talk for about 2 hours on the OSSC changes, and then we'll have a short break, and then Jody will come in and she'll talk about the energy code changes, which are actually are quite involved. And then after that, we'll have we'll have an open session where we'll have questions, and we'll go from there. During my presentation, if you ask me questions as I go along, I'm comfortable doing that, and I'll let Jody tell you how she wants the questions to be answered with her, and we'll go about that way. With that, thank you very much to AI for the introduction. I think that's much better introduction than I could have ever hoped for, but yes, I have done all of those things. And actually recently Code Unlimited merged with Jensen Hughes. So when I put up the slides, you'll see Jensen Hughes. Jensen Hughes is a global code consulting firm, and we merged with them, and will eventually become Jensen Hughes Pacific Northwest Group and continue to grow and provide services to our clients as we have. Jody, do you want to turn on your calendar, your video, and we can just introduce you? Jody Orison is a senior, and correct me if I make mistakes, is a senior plans examiner at the city of Portland, highly regarded, highly respected. She has an architectural background, has a great insight into the building construction and building design and regulations and how they all work together. I worked with her at the city of Portland for many years now, and regarded her with high respect, and love to problem solve with her. And with that, Jody, add anything that I may have missed.
Only that I am very excited to have this opportunity to talk through some of the changes that the Energy Code is putting on the process piece for City of Portland, the types of forms we're asking for, notes, and even pieces during the construction process at the end. There's a lot of moving pieces. There's been a lot of moving pieces in the Energy Code over the last few years, so I'm glad to have this opportunity to explain them and talk through them, answer questions, and actually even get feedback.
Right, with that, I'll turn on my slides. Can everybody see my slides?
Yes, it looks good.
Very good. All right, so today I'm going to talk about 2021 IBC significant changes, and I'm also going to include OSSC changes. And we'll talk a little bit about where the OSSC is and what the OSSC means for those who don't know. As I usually do, I'm going to include some common areas that I find as we consult with clients that it's not a very well understood concept. So some core concepts that I think are worth discussing in this group, I will include those as well. But most of the presentation is about things that are changes. And what that means when I have so many things that are changes, that the presentation will feel a little bit disjointed. Because I'm going to jump from topic to topic to topic, but I'll try to connect the dots and keep you engaged as we go through, so that it doesn't feel as disjointed. So first of all, Oregon takes the International Building Code. In this case, the 2022 OSSC takes the 2021 International Building Code, makes amendments to it, and renames it as Oregon Structural Specialty Code. So Oregon Structural Specialty Code is our building code as adopted by the state of Oregon. The Oregon also takes the International Fire Code and puts that provisions in OSSC Chapter 4. So the Chapter 4 in our OSSC is much bigger than the IBC Chapter 4. You might remember at one point that we had an Appendix N in the OSSC in the last code cycle, and then it went from Appendix X to coming into the Chapter 4. And what it is Oregon, by law, the building official is the official that is responsible for reviewing and approving new building construction, not the fire official. The IBC and IFC written as the building official and the fire official, but in Oregon, it is all the building official who's responsible for that. And so that legal requirement is a state requirement, is why we have Chapter 4, where all the new construction are included in that portion. And then the fire department is more responsible for maintenance and that's how that works in Oregon. Oregon also keeps Chapter 34. In the IBC, the Chapter 34 was taken out and it became the International Existing Building Code. So what Oregon does is still keeps Chapter 4, and the amendments to the existing building code are in Chapter 4. So you read the existing building code in parallel with the Chapter 4 where the amendments are. So Chapter 4 tells you this section is revised, this is deleted, this is added, that kind of stuff. So it's a combination of how you read it. So essentially, the 22 Oregon Structural Specialty Code went into effect October 1st. So we are in the new cycle. But traditionally, Oregon has always given a grace period. So even though the code adopts October 1st, it is not mandatory until typically 3 months later, which is January 1st, is typically what happens. In this instance, the state is a little bit behind on getting all the publications done. So rather than change the effective date, the state has pushed out the grace period. So essentially, the effective date of October 1 becomes mandatory date on April 1st, 2023. So you have a little bit more time to get used to these code changes. Jody will talk about the energy code and the process involved with that, because as we went from the Oregon Energy Code, which was the basic code that came from the energy code, and Oregon had developed something, to now going to ASHRAE as the base code and then modifications. So our energy code is actually a much smaller book, similar to the IEBC in Chapter 34. The energy code also gives you things that are changes, and then you compare it to the base ASHRAE and use that as a combination to do that together. So and its Oregon Energy Code is still the 2021 Oregon Energy Code. In between, there was the zero code also. So we have gone through some name changes, but this is where we are on the energy code. And Jody won't go into the technical requirements because she's not, and I might use the wrong word, but she's not allowed to give technical clarifications. That is restricted to the building official. So she's going to talk more about the process, and I can talk about the code and things like that, and we'll answer your questions based on that. With that, I'm going to roll into the changes to the 2021 IBC and the 2022 OSSC. So if I don't point out that this is an OSSC change, it is a base IBC change that Oregon has adopted. One of the things that the code changed in this cycle is the definition of the penthouse. So in the code, the penthouse and the equipment platform are really the two spaces where the code especially says that it is an unoccupied space. There's many places where it feels like unoccupied, but it is occupied. I work with a lot of clients who work on the shows, and they call out the corridors and bathrooms are unoccupied. And by code, those are all occupied. They all get an occupant load, and you have to include that in your occupant load, gross occupant load calculations. But the penthouse and the equipment platform are by definition unoccupied. The penthouse did not include stairways and vertical shaft openings, and that got added in. And so why is that important? So the question always came up when you have a stair shaft coming up or an elevator shaft or something else coming up, what happens at the top of the roof? Your 2-hour rated or 1-hour rated walls, do they terminate at the roof or continue through the roof and go all the way to the top? So that was a question. So this starts answering that. I will talk about this a little bit more at the later slide where we have talked about shafts, but essentially what that means is the top of it becomes a penthouse. And if you go to the penthouse requirements, they're in chapter 15 of rooftop structures. So in this instance, this is a top of the stair becomes a penthouse, non-rated exterior wall structure everywhere around. This condition here, the middle picture where the stair is coming up and the wall continues behind it. The intent of the shafts and the stair enclosures is to prevent from fire that originates from inside the building and protecting the structure, the contents of the stair of the shaft from the fire going one way or the other. Right. So in this instance, since the wall continues behind it, that will be the rated wall that separates the stair and shaft. And then the exterior wall will be treated as an exterior wall. In this instance, where everything is on the top of the roof, it becomes a penthouse by definition. And also the penthouse requirement is it has to be less than a third of the roof below. So if you have other penthouses that are part of this and the collective area exceeds 1/3, you wouldn't become a story as well. And then it will be a different issue. The other thing about penthouses is penthouse exterior walls, the exterior walls and are dependent on the rating is dependent on separation and fire separation distance. So you have to pay attention to that. Even though your stair might be coming up, it may not be non-rated because the exterior wall might need rating. So pay attention to that. But otherwise, the code has clarified that the shaft terminates at the roof. Here's a couple other things that happen. In group F1 occupancies. F1 occupancies are factories based on factory, which manufacturing industrial is factory that comes to F occupancy. F1 is the moderate hazard, F2 is the low hazard. One of the things that got added in is energy storage systems is a new category. So this is coming primarily from lithium-ion batteries. Up until now, the batteries where we had the lead acid batteries, which were traditionally classified as incidental use, and based on the quantity of the material, you would have requirement for a battery room and then separation, things like that. When lithium-ion came in, lithium-ion has a runaway heat problem. So it can start a fire and become a very intense fire, and it is very hard to put it out. So that raised a lot of concern along many of the jurisdictions and many of the people working on it. And so there was a period in between where all lithium-ion storage becomes an H occupancy, an H2 occupancy. Now there's more research available, so it's not becoming an H occupancy, but it is becoming an F1 occupancy. But also in the fire code, there's now chapter 12 has added energy storage systems as a more explicit mitigation and management systems. And one of the things that it requires is an expert to do an assessment and develop a plan of how that will be protected. So not calling it an H occupancy, but treating it as a hazard and requiring mitigation and management through that process. The other thing that changed is water sewer treatment. Some of you might be coming from the legacy codes where there used to be a B2 and a B4 occupancy. So B2 and a B4 occupancy is converted when the code changed in the 1994 code cycle to F and S. And so the S2 or F2 are both where the contents are non-combustible. So typically water storage becomes an S2 because of storage. Water treatment become SF2 based on treatment, which is active, storage, which is passive. And so the treatment become F2, and now the code is putting that into F1 occupancy because the reality is water and sewer treatment facilities involve chemicals. Often toxic, often corrosives, and those need to be handled and pose a higher risk for all the other requirements that F2 and F1 have. So this got moved in here. The other thing that is happening in Oregon in particularly, we have a very robust wine and distillery spirits industries. So the code has been trying to figure out how to treat those industries. We have done a lot of appeals in the city of Portland where we have not classified a brewery as an H occupancy. City of Portland has published a guide about storage of barrel storage and wine storage and things like that. So there's been a movement towards recognizing this. And what is the difference? See, the wine and distilled spirits have alcohol. Alcohol is a flammable liquid, but it's also a water miscible liquid. What that means, it blends very well with water. But if you test it for the standard flame flash point test, it flashes and it comes across as a flammable liquid. But when it's mixed with water, it's very hard to ignite it. So the code is recognizing that dichotomy of the material and how it performs when it is mixed with water. And that's what it's doing. So it is now, and there were provisions in the code. So in the fire code, there was different places you had to go connect the dots across multiple chapters and demonstrate that this could be a non-edge occupancy, which is how we did many appeals in the past. But now the code is bringing that into the mainstream of the code and clearly articulating what that does. Similarly, the moderate storage group S1, the IBC did not have beverages over 16% alcohol content, so that got added in the S1. The IBC in the S2 is keeping beverages including 16% up to 16% as an S2 for storage. Over 16, S1, under 16 and under is S2, and took out the metal, glass, or ceramic containers because it's just based on the alcohol content is how they're dealing it. Oregon, now if you look at the top, the OSSC little label, that tells you what Oregon did. In Oregon, beverages over 16% alcohol content was already part of the F1. So IBC and OSSC, no change. So beverages over up to include 16% was IBC, OSSC, no change. And we have a wood barrel and bottle wine aging facilities and winery as an OSSC addition. So which is a change in Oregon. And then the moderate hazard S1, 16% alcohol, IBC addition, but OSSC already had it. So it's not a change to OSSC. And in Oregon, we are added back in wood barrels, metal, glass, or ceramic containers because wood barrels are kind of an important part of how we treated it. And that's also how we treat the F2 occupancy. So that's the connection that Oregon has had, and we're continuing forward. So it's not a change to Oregon. It will show up as a change in the OSSC, but it's kind of carrying forward. The original intent was Oregon was already doing. Here's a discussion about something that changed in the 2018 cycle, not the 2021 cycle. So in the room or space used for storage purposes that is accessory to another occupancy shall be classified as part of that occupancy. So that IBC says shall be classified as part of that Oregon, and Oregon says may be classified. So what that means is the IBC says if this is a B occupancy and this is storage, it has to be classified as a B occupancy and it's an accessory to this. So the problem with that definition is that accessory is limited to 10%, and accessory by definition has to have its own occupancy designation. So the Oregon actually clarifies and simplifies and makes it more real that it may be part of that. So it could be just part of that main occupancy, or you could classify it as a S1 occupancy and deal with it as a mixed occupancy or a non-separated use occupancy. So that becomes a designer's choice. So one of the things about the accessory and non-accessory, when do you become an occupancy? I've always used the 10% rule. If an accessory goes over 10%, then it becomes a minor occupancy within the building. So the same philosophy I would approach here, that if you have storage that is more than 10%, rather than classifying it under the main occupancy, you should be classifying that as an accessory in a separate occupancy. So the IBC statement is regardless of size must be an accessory, but I don't think that the code really intended it to that way, because the hazards of a storage should be considered beyond a 10%.
Samir?
So, yes.
Sorry, I was just going to add one thing. There's also some reasons in Portland why somebody might want to keep their storage in S instead of moving it to that B with our seismic triggers. So there's some incentives that are local that you might not want to do that shall, like he was talking about.
See, great insight. That's why I asked Jody to join us this time. Thank you, Jody. Incidental use. So I don't know if everybody knows the difference between incidental and accessory uses. So incidental uses are typically functions that are part of the main building occupancy and are part of the building. Accessory uses are very distinct functions that are become part of the main occupancy. So for example, a boiler room or the furnace room that is common to most buildings becomes an incidental use. An incidental use is actually a room or an area that by nature of its operation can be a more hazardous room. And so incidental rooms and storage rooms used to be considered incidental rooms, and now they're considered accessory as part of the main occupancy. That's the change that took place. As we have started going into the mass timber construction, the codes are evolving associated with that as well. And one of the things that is changing is in type 4A and type 4B construction, more than 120 feet in building height, require fire pumps with connections no fewer than 2 water mains. So if you go to the high-rise provisions, that's where this provision comes from, chapter 4. And in the past, when this first came into the code, I think it's a 2006 edition, it first came into the code, is that there were 2 separation requirements. Then the code wanted to change that to 420 feet, but that was mislabeled as 120 feet for a couple of cycles and then changed to 420 feet. And now with mass timber, that provision is going back to 120 feet for mass timber. And the reason for mass timber provision is there is still concern about mass timber being wood and therefore becoming a major fire hazard. There is no basis for that assumption, but this is where we're coming from because we're correlating mass timber to light frame construction. And one of the concerns is if you have a very tall mass timber building and there is a big fire and the fire department is here and their ladders cannot go higher up. And if the water supply is lost, then what happens? So this is in abundance of caution is the approach that this is taking. It might stay in the codes forever. It might get changed as we get better understanding that this is one of the things that is coming out. That requirement, no fewer than 2 water mains, is a significant requirement. So pay attention to that. Smoke control. So one of the things about smoke control is the atrium concept has evolved. So in this code cycle, the code has clarified the atrium definition because I keep coming into people who say a 2-story opening is an atrium. And the answer is no. The 2-story opening can be treated as an atrium. There are multiple ways you can protect the opening. Atrium is one of them, but that's a different story. So in this one, what has happened is the code is saying that if you have a 2-story opening and the rest of it is separated by a shaft construction, then the 2-story opening can be treated as a 2-story opening and does not need to be separated from the atrium above with the provisions of the shaft. It's separated as a shaft opening, then smoke control is not required connecting that. So this is an appeal that we've done in Portland quite a bit. This is something that we have done in many other jurisdictions where the question comes up, I only have a 2-story and commonly it's a 3-story building that happens where the 3rd story is physically separated, and how do we deal with that? And so the code is now giving a prescriptive path. I'm sure your architects will find a way of doing something different in the code says, but at least this gets us closer to where most common questions come up to us. Another thing that gets clarified in the code is the enclosure of atriums and connections. So the code allows 2-story openings to connect, but you cannot connect 2-story, first and second story connected here and the second and the 3rd story connected here because then it connects together, right? So the question then becomes, how do you deal with an exit access stair or an escalator stair, escalator that is going through? So one of the things is that in an enclosure of the atrium, the horizontal is not required between atrium opening for escalators or exit access stairs. So this is the connection here where this is the separation across from the atrium, but this is permitted because it is protected as long as the smoke control and everything is worked out. So these are kind of clarifications in the code, how to deal with it because the code was silent on this before. Another thing that is changing, not a big deal for most of you, but in parking garages, there used to be a requirement for drainage. That requirement was taken away, and now it is being brought back in. So there was a requirement for approved non-combustible, non-absorbent materials, and then the S2 parking garage exception that allowed no drainage required, that went away, and so therefore now it will be required. So we can have a traditional kind of trench drain, or there's very thin drains that can be not very visible but still work at drain. There are multiple options to solve those. Door construction, that requirement for doors in an I2 occupancy, and whether you have louvers or you've undercoat doors, that was more specifically spelled out in the code now. And it's a clearance of 2/3 inches in having louvers when you have conditions permitted to have that. Those are just aligning with NFPA 101. NFPA 101 and the I2 occupancies will continue to have differences. If you look at the basic business proposition, they both need to sell their books. And if they're all the same, you'll only buy one of the books. So there's always going to be a difference between the two. But there is a concerted effort to kind of match them and have them be consistently together. So people are not trying to meet two very different code requirements. So another thing in the I2 occupancy, so which is hospitals and healthcare related occupancies. So care suites, as they used to be called just suites before, are now called care suites. That change took place just last cycle or the cycle before, I don't remember exactly, but that has become part of it. And the exit access from other portions of the building not classified as square suite shall not pass through a care suite. So the whole concept of the care suite in a healthcare facility is that it is a protected group of rooms that are given some relief from other requirements. And so making sure that nobody else goes through those rooms to make them that they're independent and meet the intent that the code has for that is important. So another thing that is have a door leading directly to exit access corridor, horizontal, and 100-foot travel distance within a care suite. An additional door leading to exit access or exit adjacent suite is the requirement for that, which is part of the means of egress. These were part of the NFPA. It was not clarified in the IBC. Now IBC is aligning with NFPA on that one. So it's not a change for those of you who've been engaged with it, but it's just trying the two codes coming together and aligning better on that issue. So here's another thing that the code is doing, which is more clarifying the code intent and codifying it. So if you go back to the firewall requirement, the firewall originally was a building separation. Then in the last code cycle, I think 2015, it started in 2018, it made additional changes. The code clarified that the concept of firewall is to separate two structures of different construction types, having for their allowable area heights and storage requirement. So for example, you could have look at the two structures as a single entity for means of egress, for example. So the code limited what the purpose of the firewall is. By doing that, one of the things they did not address was control areas. Control areas are where hazardous materials are stored in the building. The code has a compartmentalization concept that allows multiple compartments to allow increased amount of chemicals. It is control areas, lab suites, both do the same thing. And when interpreting it in real practical purposes, we always said that once you have a firewall on either side of the firewall, you can start over with control areas, but it was not very clear in the code, especially with this language that was added. So now that is clarifying in the code. So that shows the intent of the code, that the firewall was intended to separate other areas as well, but where it is not explicitly stated, you could combine it. So here's another thing about firewalls in general. The firewall requirement is to separate buildings. If you go back to the legacy code, it was called area separation wall. In the legacy code, there was a provision for the firewall or the area separation wall to be structurally independent, but is never read that way or never enforced that way throughout the West Coast. So our firewalls or area separation walls were built like fire barriers. They were higher fire rating. So typically fire barriers went for 1 or 2 hours, and area separation walls went to 2 to 4 hours. So up to 4-hour rating were the area separation walls. So now the concept of firewall is structurally independent. Very hard to build a structurally independent wall, because that literally means the wall stands by itself as a cantilever structure, which is expensive to build and difficult to build. So most commonly, as the building gets taller, you have set up 2 walls, which the code permits. The IBC had a table that says, how do you build 2 walls? But right now it refers to NFPA 221, for the requirement. So if you have a 3-hour firewall requirement, sorry, if you have a 4-hour firewall requirement, you build 2 3-hour walls. If you have a 2-hour firewall requirement, you build 2 1-hour walls. So it's kind of an explicit table in the code. So the question that comes up is I have a 2 2-hour walls. Does the structure providing lateral bracing for that wall have to be fire rated? And this goes to the basic concept in the code about making sure that the structure holding up the wall is rated so the wall can keep standing. So in this instance, it is unique, and this is clarified in the NFPA 221, more so in the building code. So because there are 2 walls, one building collapses, it takes that wall down with it. The other wall is still standing, and that is a rated wall. So the structure collapses, and because now structure has collapsed, it opens up the fire and there's no ceiling above. So the fire is going vertically up. So the intensity of the fire and the exposure on the wall reduces. And then that fire to compromise this wall before it affects the other structure. So this 2-hour rated wall is going to protect the structure behind that wall. So essentially the code is saying, as long as the wall is load bearing, the load bearing components of the wall are holding it together, the structure that is behind it doesn't need to be fire rated. Here's how you terminate firewalls. When firewalls come to the exterior of the building, it is required to have 18 inches beyond the wall. Most commonly, you don't see that. So what is going on? So commonly, there are 3 conditions: a combustible exterior sheathing, non-combustible exterior sheathing, and non-combustible exterior sheathing with sprinklers. So based on that, you can protect the wall, perpendicular wall, terminate the firewall at the end of the building, and have perpendicular walls either protected for 1 hour or just non-combustible sheathing, or nothing required because you're sprinklered and non-combustible. So similar to that condition, when you have 2 buildings next to each other, how do you terminate that building? So the code allows you 2 paths. So until this 2 paths were defined, we were commonly using this condition where you have a building here and a building here, and this firewall comes through. The firewall in this instance, when the 2 buildings are on a common lot, becomes the assumed property line for that. The code allows the designer to pick the assumed property line, but once you do a firewall between 2 buildings on the same lot, that is the assumed property line. So you bring the assumed property line up to this structure, and then it goes either straight out, or you can do other things. You can jog it, straight it. It's up to the designer's choice how you took it. And based on that, for example, in this instance where it's right at the property, this wall becomes a 0 lot line. The wall is 0 feet for the fire separation distance and treated that way. This other wall, which is perpendicular, now has 20 feet or more, and it can be treated that way. So that's how you design the exterior walls. Or the code says the alternate is you treat them as the buildings, as long as this angle is less than 180 degrees. You rate 4 hours on either side, 4 feet on either side with a 1 hour, and protect the openings. And then you don't have to worry about showing an assumed property line. This is the easier method in terms of compliance. It is often the challenging position when an architect wants to keep a fully glazed facade, and that becomes the challenge. So one or the other are the prescriptive paths that are available to you by code. Cross-laminated timber. So Oregon has been ahead of the ball game in terms of cross-laminated timber. So we adopted mass timber very early, and cross-laminated timber is a subset of the mass timber. So cross-laminated timber is timber pieces that are perpendicular to each other. So one goes north-south, the next layer goes east-west, and the below goes north-south, is how cross-laminated timber is prepared. There is glue laminated timber, or glue lam as we know it. There is nail laminated timber and parallel strand lumber. So there's multiple ways of creating mass timber. Mass timber is thicker engineered wood, essentially, and it's different than heavy timber. So cross-laminated timber is where we have gotten engaged with, and it's called mass timber in the general materials. And it's a very, very exciting change in the code, and very helpful in many aspects. So in the last code cycle, Oregon adopted mass timber, but it adopted as an appendix. So Appendix P is where the mass timber provisions were brought in. Now that and those were the provisions in the 2021 IBC that Oregon pre-adopted before the 2021 came in. So that's one of the things that Oregon did, and those becomes in Chapter Fee, but now it will go in Chapter 5 or Chapter 4, Chapter 6, where all construction types related activities go. So you will now see a table that shows construction type, type 4A, type 4B, type 4C, and has all the requirements listed up. As you might know, NS stands for non-sprinklered, S stands for sprinklered. So this is the construction type, and your number of stories based on sprinklered or non-sprinklered is requirement. It is kind of useful to know that type 4A was based on Brock Commons Tallwood House back in Canada. Type 4V was based on the framework building that Lever was doing here in Portland, and it never actually got built. It went through the design process, it got to the plan review process, but never got built. And then the construction type 4B was based on carbon 12 building. I think Pat Architecture did that, and that is basis for the type 4B building. So this is where it came from. In terms of the allowable area, so a lot of times people ask questions, where do the allowable areas come from? They look so precise. Is there engineering or science behind it? Yes and no. There was a period in code where the construction type and allowable area were based on assumed field load. The New York building code, the New York State code, or actually not the building code, had that provision for the longest time before they moved to IBC. So through 2003, 2004, they had that provision. They were actually classifying that based on fuel load inside. But that's not what it is right now in the code. It is quite a bit based on traditions. It is worked thus far, it's not broken, let's not fix it kind of thing. So mass timber evolved as type 4C is 1.25 times type 4 heavy timber factor. So 4C is slightly better than heavy timber, 4B is twice better than heavy timber, and 4A is 3 times better than heavy timber. That's how the table was created when it was brought into code. In part of it is there is no rationale one way or other, but the code needs to give a precise number, because in the end, if you don't give it too much a precision, it becomes a performance code, and it becomes very difficult. We're so used to prescriptive codes. So one of the things that did is, once they did this, they actually took the groups that were considered a higher hazard, group I and group H, and their numbers were adjusted down to compensate for elevated hazard for these occupancies, especially in the wood construction, is how the heavy timber related. And why do I want to tell you this? Because it's always good to understand the code intent and where the code comes from, because this is still an evolving construction type. And there's challenges in how you can build it in terms of the size of the members, things like that. So here's kind of a cheat sheet of the construction type and what is allowed for the common occupancies that most commonly come across for this building type. And you can see that the B occupancy in type 4A is 18 stories, 270 feet, and 12 stories type 4B. So 12 stories is the type 1B allowable, and type 4B is comparing. Type 4A is unlimited. Sorry, type 1A is unlimited. Type 4A is limited to 18 stories, but still substantial. And if you go to I2, then the heights are getting restricted further down as there. So there's some, you can see that nuanced approach. So pay attention to the details as you go through. Here's an example of what I was talking about. So there are actually 2 buildings that we worked with. One is called Catalyst, and one is the Flatworks building. So the Catalyst building was not in Portland, the Flatworks was in Portland. So the Catalyst building, the structure is multiple joist space close together. So the structure is very compact, but the Flatworks has deep glue landings, almost 3 feet deep. And so that building, actually the number of stories met the type 4C, but the building height exceeded and became a type 4B. So paying attention to structure becomes important. And those are the issues that you have to pay attention to in mass timber construction. How do you want to detail it? How do you want to build it? What's the structure depth? What is your advantage? So here's the basic requirements of what it is. So type 4C, if you look at all the components, the basic structure is 2 hours versus type 4 heavy timber, it is 1 hour. So by using higher rating for the structural systems, that's where the increase in allowable areas comes from based on that. And then type 4B is the construction of the structure doesn't changes, but the exposed wall and ceiling changes. And type 4A, the rating of the structure changes or increases in exposed, there is no exposed wood inside the building. So the type 4C is what everybody loves. Type 4A, most people don't like, but the reality is that type 4A is still a very efficient system. And eventually, as we get past the aesthetic of the wood and look at use as an efficiency factor, I'm pretty sure that we will start seeing more type 4A construction as well as an efficient way to build buildings, because it comes as a preset components. It's like a Lego set, gets assembled very fast, and that might be where its advantage gets shown up. But right now, type 4B and type 4C are the two that are more prevalent buildings that we see. In exterior wall requires gypsum protection, so you don't get exposed wood there. And then concealed spaces have to be addressed as well. As you can remember, type 4 heavy timber, concealed spaces was not permitted. Under the type 4 ABC, concealed spaces are permitted and you have to mitigate them. And now in this code cycle, there is change to type 4 heavy timber also for that regard. We'll talk about that in a little bit. So in the interior spaces, the 20% ceiling or 20% walls, 40% walls, were based on the area of the room. So you could have exposed wood on the walls and some exposed wood on the ceilings in the construction type 4B. In the type 4A none, type 4C, everything can be exposed. So Oregon is changing that and allowing 100% of the floor to be unprotected at the ceilings. So where you had ceilings that were partially wood and partially protected, you could have complete wood ceilings in type 4B in Oregon. The walls are still at the 40%, but the floor is changing. So the 20% was changed. And this is based on the 2024 IBC changes. This has been, the Tall Wood Committee has been looking at this for some time, and they have done testing and they have demonstrated that actually ceilings do perform well and ceilings don't need to be protected in type 4B. So that's where it's coming from. So the protection of structure. So the code says thou shalt protect it per wood alone, or you can protect it by adding material to it. So you can get a composite panel for fire rating. So if you look at basic fireproofing, so the sprayed fireproofing on steel essentially is providing an insulating material around the structure to prevent the heat outside of a fire from reaching the structural element. That is the same thing that wood is doing, is that allowing a insulating material in front of it that will protect and allow it to be protected for this. The other alternative is that you take the wood component and oversize it. So if you need 4 inches of depth for your structural regions, you add 2 inches to it, make it 6-inch slab, and that extra 2 inches becomes the sacrificial wood that is okay to burn out as part of the protection for the system. That way you could exposed wood all the way across. When you had gypsum, it protects the wood, but you lose the wood exposure. That's what it does. The code allows you a calculation method to do it. So the code takes this in and says that you have to take rating of these things, and it takes you to NDS chapter 16. So you have to pay attention to that. NDS, this is an example of how 2-hour rating can be approached by adding 2 layers of gypsum. But when you add only 1 layer of gypsum, NDS deducts 50% of that ability. So it's a different equation you have to do to calculate it. So have somebody pay attention to the calculation, but that's how you do the calculation. Another thing that comes up commonly is the I find a lot of the code or the mass timber buildings are hybrid systems. There is benefit that the wood brings, but there's also benefit that steel and concrete bring, and you can combine them together. When you become a hybrid system, then the protection of each of the elements becomes a different story. So the paying attention to how these systems connect together and if that is a weakness or not. For example, when wood is exposed to heat, no problem. When steel is exposed to heat, it's a problem. So this needs to be protected. You can protect the steel by traditional sprayed gypsum or sprayed fireproofing gypsum, or even extra wood that gets spruced, and that will be the sacrificial wood. But that design detail needs to be developed in combination and understood better, especially paying attention to movement. If there's a movement issue, the mass timber is more rigid, steel is more ductile. So paying attention to the structural design as well as the fire protection is important. So one of the things about calculating fireboard membrane systems, there is a general wallboard membrane that gives you calculations, and there is a mass timber specific requirements as well that comes through. So mass timber addresses some of the elements. This is the general wallboard membrane requirement, and this is there. This is also in 722.6.2.1. So these wall membrane and calculated fire resistance is part of the already part of the existing system, but it was co-opted into the mass timber, and that's where we work with it. One of the questions that often get asked is I have a mass timber floor and I'm going to put gypcrete on top of it. Does that give me fire resistance? No, it does not, because the protection needed is from the bottom, and the gypcrete above does not protect the wood from the fire exposure. The other thing that comes up quite commonly is the fire rated joints. If you look back to this structure, if you see the joints are the connectors are all outside the wood and exposed. The more common now are the hidden connectors between wood and things. And these become very good because they are actually easy to install, and you can come in pre-drilled, pre-assembled, and just connect it together, just slide it in, it works. And you can put fire caulking around it and gives a good solid seal. So these are actually better systems. The early mass timbers that started were all part of the, become more of an extra effort for intumescence on top of that, or wood covering on top of that. And then as these systems came out, everybody goes to hidden connectors, and it has become much better that way. Through penetrations in mass timber are different than standard. They are specifically listed and approved for mass timber. And the issue really is, if you look at what happens when a system is connected to a true penetration. If you look at wood, fire rated wood assemblies, at the bottom of it is the chipboard or non-combustible element. So the fire rated structure almost always, and when exposed to the exposure that is exposed to fire, is non-combustible. In mass timber, the exposure is wood. So when the fire hits this condition, for example, where the pipe is going through and starts hitting it, the fire will burn around the pipe and make that gap bigger. So that's a concern that has to be addressed as well. And so these systems are different systems that will maintain that rating and not allow the gap to go through. So these are tested for specifically on mass timber, and those are the ones that you need to use for it. Here's another thing that is not a change in the code, but I wanted to bring up because that's a common miss. So for mezzanines, the mezzanine area is limited to 1/3 of the room or space it is located in. Still, many architects think of mezzanine as 1/3 of the floor area. It is 1/3 of the room that it sits in. So that is important to do. And the second thing about mezzanine construction, the code does not clarify what the mezzanine construction is, but the code commentary has clarified the mezzanine structure has to meet the building construction type. Therefore, it has to be fire ratings of the building has to be done. There are mezzanines in type 1A and type 1B buildings that are just non-combustible mezzanines that are built in, but those need to be approved as an alternate based on limited size, contents, whatever. Otherwise, it needs to meet the construction type of that. On the other hand, the equipment platform, the code is silent on the fire resistance of the equipment platform. So equipment platforms could be non-rated because the code does not clarify what that requirement is and does not mandate it. Here's another aspect of the code that is not commonly understood. When the code came in with the non-separate uses, most designers now want to do non-separate uses. There is still a place for mixed occupancy. And it's important to understand the difference between mixed separate occupancy and mixed non-separate occupancy, accessories, and all those components the code designs with it. So let's take a look at this. So in this particular instance, let's say there is a B and an A occupancy. And then in this instance, the total building area is 9,500 square foot. You have B and A occupancy. The A occupancy, if you do non-separated, then you have to calculate the building allowable area as if the entire building was an A occupancy. In this instance, the entire building could be A occupancy. So having a combination B and a non-separated A and B and designing to the most restrictive A occupancy is the solution, which is what we commonly see. But it's important to understand that the A occupancy and B occupancies and which of the occupancies you have, because each, even though it's non-separated, you still have to identify the individual occupancy. You cannot just call it A occupancy. You have to call it A occupancy and B occupancy and meet all the requirements of each occupancy outside of the allowable area requirements. So if you do a mixed occupancy and separate occupancy, so A and a B are separate occupancy. So in this instant, the A occupancy will have a fire rate separation between the A and the B. You will calculate the mixed occupancy ratio. So you take the actual area of the A occupancy divided by allowable area of the A occupancy, and you'll take the actual area of the B occupancy and divided by allowable area. So it's 0.62 and 0.38, and combined together is 1 or under, and it's okay. There's question. So, okay, Jody Orison has added in the chat an option for chip and char protection of wood, 5A construction, and there's a link that she's seen. If you want to capture that, go ahead and use that and copy it down, so you have that. So the mixed occupancy separate uses, you can combine these two occupancies into two separate occupancies and do it. So another way to look at this is an accessory use. So as we discussed, accessory is limited to 10%. So in this main occupancy of a B occupancy, if you have an A occupancy space, which is 10%. So one of the things about 10% and accessory use in multi-tenant buildings and otherwise important to understand, if the building has 2 tenants, then the common question comes up is which tenant gets the 10%? Sometimes building officials pay attention to that, and sometimes they leave it up to the owner to manage that. So you can allow 10% accessory use, and if one tenant comes in and takes away the 10%, the other tenant is left without that. So it's as the owner makes the decision who gets that privilege or not. Building code wise, it is 10% of the floor area and 10% of the main occupancy. The other thing to pay attention is A and B. If you say that this is going to be 10%, how does the building official ensure that down the road this doesn't grow and becomes 20% of the floor area? So that is an important question that often will get asked in the plan review process, and you might be asked to demonstrate a physical barrier or something like that to ensure that the A remains on that size and does not grow more. And when it does change, then there is an ability to administer the requirements based on that. So that is one of the things. So here's the discussion about mixed occupancy and accessory uses and how does it all come together, and how does it matter in the end. So for example, in this, the one on the top is a mixed occupancy. And if you can see the occupancy, the calculation of ratios exceeds 1, so therefore it's a non-compliant. At the plan below, the A3 and the F1 were moved to accessory uses, and A1 and S1 kept as mixed occupancy. When you move the A3 and F1 to accessory, the actual area of that gets moved to the main occupancy. So the purpose of accessory use is those areas going to the main occupancy which was 54 grew to 61, and you do the calculation based on the main occupancy. You don't have a fire rated separation between the two, but you are limited to not more than 10% of the floor. So allowable area, oftentimes people look at the allowable area table and assume that the allowable area listed in that table is allowable building area, is actually allowable floor area. So what it does, it gives you a maximum floor area for the building. If the building becomes 2 stories, then your sprinkler increases for multiple multi-story building sprinkler increase. And the area that you get in the table is allowed for each story. So you can double the area that is in the table. If you go to 3 stories, you can triple the area. If you go to 4 or more stories, you're limited to 3 stories for most occupancy, except NFPA 13R allows you 4 stories increase, which is a different equation, and that is not explicit in the code, but it is implied in the code. So technically, you're allowed 3 multiplier of 3 for building compared to the floor area that you get. So structural fireproofing, so similar to the mixed hybrid structure I talked to you about, when you have a structural fireproofing, the structural fireproofing is required for the load-bearing component of the structure, not the lateral bracing component of the structure. But the code has now clarified that for lateral bracing, that protected shall from a distance not less than 12 inches or should the entire length attachment when it's less than 12 inches. And the reason for that is when this steel piece is heated up and it is connected to the structure here, this heat is going to go through that structure and compromise this structure. So extending that protection is a way to really protect this structure, not necessarily that structure. Here's the termination of the shaft at the top of the building. So the shaft enclosure, you can terminate it at the roof, you can take it above the roof, or you can terminate it below the roof. And so the shaft comes up to the underside of the roof structure. The structure above has to meet the construction type, but openings don't need to be protected. So for example, if this is a type 1A building, then the roof would have to be 1.5 hour, but you can have an opening here within the shaft as long as the opening does not go further out. As it is within the shaft boundary, you can have an opening so that ducts penetrating through that don't need to be dampened going up. And the structure has to meet the building structure to construction type. If the shaft ends below the building, then top of the shaft has to meet the shaft requirement and close it off. Any penetration through there would be fire stopped or dampened. If you go above the roof, then the structure above the roof is now a penthouse. Because essentially the intent of the shaft is to protect from fire migration between floors. It's a vertical opening protection. Once you get outside the building, the code does not care. Structural frame requirement. The columns are required to have fire resistant rating and need to be individual encasement. So the columns get wrapped in this. This is a common question that comes up if the column is encased in the wall. The column needs to be individually encased. The primary structural frame members, other than columns, do not need to be individually encased if they're not supporting more than 2 floors, more than 1 floor or roof, and not load-bearing wall. More than 2 stories high. So there's exception, but columns always need to be individually encased. So one of the things that did happen in the last code cycle is the horizontal assemblies can be protected by membrane or ceiling assemblies. So essentially, these assemblies allow you to consider that to be a full horizontal assembly, can be a ceiling assembly like this. These walls are a different thing. So one of the things that code did clarify is stud columns, boundary walls located entirely within bottom and top slabs. We have a plates top and bottom. So they're not going through and penetrating a hole through. Those could be treated as the wall assembly. And this is kind of a practical solution because oftentimes in walls, you have multiple studs come together for load bearing capacity, for point loads, and treating them as columns is a very difficult task to do. And so these are technically load bearing walls, and this becomes part of that. And so there is an exception for light frame construction that was granted. So the fire exposure on one side for exterior walls, this comes as a common question. There is not that many UL assemblies that are for bearing wall rating for fire on one side only. So typically in a building, the fire exposure is expected to come from inside the building. So your building is your exterior walls are protecting other buildings, not the other way around. So your wall rating is based on fire inside. So if you have adequate separation, which is the code says 10 feet, then you can have the fire protection on inside and not have it on inside. So it's an asymmetrical wall rating. And then the exterior is sheathing, and then and cladding is the exterior wall, and then gypsum and rated assembly is inside. That's the fire exposure on one side when you go through that.
Also, Samir, on that one, Portland will accept the walls that are in that type 3 code guide. The ones that are more than 10 feet talk about some different options. Those walls weren't tested, but we do accept those for even for buildings that are not using the type 3 code guide. You can use those wall assemblies for fire exposure from one side.
Very good. So in the types of construction, one of the things, even though this is not a code change per se, one of the things I wanted to point out to everybody is the similarity. So type 5B, type 3B, and type 2B are all non-rated construction. So the B is the non-rated construction, but type 1B is not non-rated. So the type 5B, type 3B, and 2B are non-rated, and the ratings come from there. Type 5A, 4A, type 5A, 3A, and 2A are all 1 hour, but type 1A and type 4A are similar in construction. Type 1B and type 4B are similar in construction, and type 4C is its own thing, and heavy timber, it's its own thing in the construction type. So if you kind of start looking at what do I need to do, there's similarities in these ratings. The footnotes to table 601. So roof supports are permitted to be reduced by 1 hour, where supporting the roof only is the issue. So the framing members, so what that typically means that if you have type 1A construction and your primary structural frame is required to be 2 hours, then you can reduce to 1 hour, or if it's reduced to 2 hours, you can reduce to 1 hour, but you cannot reduce to less than the 1 hour required is where it comes. And then group F, H, M, and S occupancies, except these, you can have 20-foot construction and then protected by fire retardant treatment. So here's what it means. So if you have a roof that is completely 20 feet above, then you can have this structure be be unprotected. But if you have a mezzanine or something like that, then this is still protected because it has to be 20 feet above everything else. I have seen appeals and alternates done where part of the roof is protected, but not all of the roof to protect for this. But the code prescriptive path is if you have something like this, it's not. If you didn't have this, this is 20 feet, it could be unprotected structure. So the key thing here is that the F, H, M, and S are exceptions because these are moderate and high hazard occupancies, where the fuel load is expected to be higher. So fire retardant treated wood members shall be allowed to be used in such unprotected members. So this is additional clarification that you can add to that. In heavy timber, complying with 1 hour less fire resistance required. So essentially by prescriptive path, heavy timber is allowed to be equal to 1 hour fire resistance. So if you need 1 hour roof and combustible materials are permitted, you can use heavy timber element without justifying the rating of the building. So here's the changes that OSSC does. So this is the reduction is not applicable to occupied roofs or roof supporting roof structures regulated by vegetative roof, etc. So Oregon is adding that amendment to that provision. It is also clarifying the rating of joints, penetrations. This shall be used. So this one is an Oregon amendment was put in place, I think, last code cycle, which has to do with PT slabs and what opening protections are required, and allowing the floor slabs to be 2 hour rated versus it became primary structure, it became 3 hour rated. And then here's the additional component that was added to that. So these two were added in the notes versus a specific code change. So that's what they were done as part of the requirement for PT slabs. So it's very unique to Oregon. We just talked about this and how this works. Additionally, fire retardant treated roof in type 1 and type 2 construction, fire retardant treated wood is allowed in roof construction, including girders. In type 1A construction, only greater than 2 stories roof construction has to be 20 feet above to use FRT. So there's limitations on how you can use FRT, but FRT is permitted in the roof construction. That's why you see type 2B buildings with roof construction above them. So exterior wall ratings are based on distance to property line. And this used to be table 602 before. In the 2021, it's moved to chapter 7. So it's not going away, but it's been relocated to chapter 7. So the fire ratings and opening protections are all together in that one chapter. 4A, 4B, and 4C were all picked and added into that category. So they're now combining as expected. 1A and 4A are equal, 1A, 1B, 4A, 4B are equal, and then the rest are all aligned together is how it is done. So Portland has fire requirements that are not in the building code for all wood buildings, not just mass timber at a certain height while all under construction. So those are Jody's point. Jody, do you want to add to that? Is this the same thing you mentioned or more than that?
No, I was trying to answer the question that was in there
Okay.
about the piece that was the piece about buildings under construction and the fire safety requirements. The building code doesn't have them. The fire code covers that.
Yes. Okay. Exterior wall opening protection. So exterior wall percentages are to be managed based on each floor. So the percent rating is by floor, and then the exterior wall separate distance, fire separation distance, is measured perpendicular to the wall. There was a period when the code allowed you to measure that perpendicular to the property line, and now it is perpendicular to the wall. So some of the older buildings, if you go there, you might find that that was the basis for it. And today's code, it is perpendicular to the wall. So based on that, your opening protection can vary based on each wall. And then it is also depending on each floor. For this example in the commentary shows that this wall is 20 feet and the next floor is 15 feet and floor above is 9 feet. And that is permitted. In a project that we did in Beaverton, we actually had the assumed property line jog. Both the buildings were flat. We jogged the assumed property line and measured the opening percentages based on that. This was a parking garage and they didn't care about openings above, but at the bottom was an entrance to the parking lot. And this was a theater, and the wall below was a back end, and they didn't care about openings, but above they needed. So we were able to jog the assumed property line. And the firewall you cannot jog, but assumed property line you can jog, but nobody had applied that vertically. It's commonly horizontally. And based on this provision, we applied that vertically as well, and the building official approved that. Exterior wall openings, just a general note, is based on fire separation distance, but there are also additional requirements like party walls, not allowed to have openings. Fire walls have limited opening size, non-sprinkler, 156 square foot sprinkler, but there is an exception, but 25% of the wall length. So there is, people sometimes miss these requirements. The fire barriers, again, 156 or 25% of the wall length. And there are some exceptions to the 25 in the fire barriers compared to fire walls. Fire partitions, openings based on wall requirements, smoke partitions, restrictions on smoke migration. So these are kind of the unique things that often get missed. So in the code, now type of assembly based on opening protection. So in the code, last code cycle and this code cycle, there's changes. And ASTM E119 tested, or there's also a term called fire protection and fire resistance that the code now uses. The fire protection assembly is fire door assembly, tested assembly. Fire resistance assembly is tested as a fire barrier or firewall. So ASTM E119 tested is a fire resistant tested. So as you go through these door and window openings, pay attention to that. So the wall assembly is 4 hour. The door is not, it is either a fire door of 3 hours, but within the fire door, if you need a vision panel, that has to meet the ASTM E119 test. So essentially a 3 hour door does not have a glass in it There are some doors that have glass in it that is allowed, which like 1.5 hour, they tested as a door with the glass in it and permitted for this, but in this case, that glass has to be fire-rated glass, meeting the fire barrier, firewall requirement. So that's the kind of the nuanced understanding of how to read these tables. Rest of it is very similar to what you're used to, just understanding what goes where and how it is put together in that framework. So similar to that wall and window assembly. So this was for the doors. This is for the windows. There is requirement for labeling that is coming. So W stands for window, D stands for door, H stands for host stream, O is for opening protection versus wall protection, and XXX are typically the minutes. So this one, for example, says opening with the host stream protection for 45 minutes, right? And this one says window for 60 minutes. So this is how the labels will be there and provided and read through. So let's take a short break. I'm going to take a 5-minute break and we'll come back and start here. So right now I've got 10:15. We'll come back at 10:20. All right, we can get started again. So I'm up. So let's see. Okay, we're generally doing good on time. We're managing the time well, so we should be okay overall. All right. So then here's a couple of things that are happening in the sprinkler realm. So one of the things that I commonly get asked is oh, I don't know what the sprinklers are. The fire marshal will tell me what to do. No, the sprinkler requirements are all in the code. The other thing I get commonly is I have to do whatever the fire marshal tells me to do. No, the fire marshal has to enforce the code. So they can't just make up their requirements. So understanding the other aspects of the building code besides the walls, doors, and windows is kind of an important part of knowing how well your plan review submittal will do when you submit for review. And it is clearly articulated. It's just that many architects don't even look at those chapters. So chapter 9 is where the sprinkler requirements are and descriptions are. They're not complicated, but if you're not familiar with it, then it feels very overwhelming. Feel free to reach out to us. That's what we do. We help everybody, and we love to read codes. And during lunchtime, if I don't have a good book to read, I'll open a code book. So I'm that kind of a code nerd. So always come ask me questions. I'm fine with it. So F1, M, and S1. Again, these are the moderate hazard occupancies. By definition, these have more fuel content, more combustible content, and can have bigger fires than F2, S2 occupancies. Within those categories, there's some special categories that the code wants to pay more attention to. Woodworking operations. So the woodworking operations, besides the fact that it has combustible materials, are likely to have more combustible materials, also are likely to generate wood dust. And the wood dust is a component that I'm not talking about right now, but is an aspect of the code that was not given enough attention, say 10, 20 years ago. It has evolved in the last 10 years plus. There's a lot more attention paid to it. OSHA has paid attention to it. There's better standards. People are more aware of it and better management because there's potential for explosion hazards that happen through it, besides just a fire hazard that exists with it. And then the woodworking operations in excess of 2,500 square feet that generate flammable combustible waste are required to have sprinklers. This is a revision. This is a requirement that was in the fire code, but now the building code is coming. This is something that is happening in the code over time. So the code would have requirements is one place here and another place here and another place here. And then the base BOCA code, or the National Building Code, which was the second component that merged with UBC. The legacy codes were Uniform Building Code, the Southern Building Code, and the National Building Code. The Southern Building Code was in the South, was the weakest of the two. The Uniform Building Code and National Building Code were the stronger codes, and one was on the East Coast, one was on the West Coast. And then the National Building Code, or the BOCA code, Building Officials and Code Administrators Code, was actually the model that our commentary is based on. UBC did not have a commentary, it has handbooks. So we now have a handbook and a commentary. The commentary came from the BOCA model, where each code section was explained, and that was brought in, and that is very good. BOCA also did a good job of coordinating everything. So BOCA always had that in the sprinkler chapter, oh, by the way, there are 20 other sprinkler requirements in these sections, and that was just listed out in the code. So those are kind of things that the UBC side learned from the BOCA side and has come back into it. So as you go through and see the code changes, some of the code changes are administrative changes to manage the process so people can see things. One of the perfect examples is electrical rooms. So electrical rooms, when you have a high voltage or high wattage requirements, there's the electrical code requires 1 hour separations, rated walls, panic hardware, things like that. And that would be commonly missed. So now that provision was brought into the code a few I think 10 plus years ago. And so it's more prevalent. People know that it is required and it is provided. So the purpose of codes is not just to write it, but make sure it gets implemented. Safety doesn't happen by accident. So you have to make sure that even somebody who's not very familiar with the codes can follow it and get a safe building. So that's something that you'll see in the codes that are happening. And then suddenly you will say, oh, this got added in the code. Many times it was already there, just not obvious to a common user. So that's one of, for instance, 2,500 square foot woodworking operations required sprinklers, whether even the building is not sprinkled. And there's requirement is different based on hazard. That takes you to NFPA 13, but at least this gets you thinking about it. Throughout F1, S1 area, that includes preparation storage of distilled spirits. So we talked about the code recognizing that distilled spirits and wines are not as hazardous as 100% concentrated alcohol storage, distillation, distribution kind of stuff. But at the same time, it is a moderate hazard, is the code has recognized. And it is a special hazard that needs to pay attention to. So part of that requirements to not make it an H occupancy was to add other requirements. A good example of that is the lab suites. The code allowed lab suites to go beyond control areas for hazardous material content, but less than H occupancies, and added provisions that were optional for control areas. So the code is managing. If you look at the codes, one of the biggest problems with the code is that it is based on only fire as a hazard. It is learning, but still not fully understood the concept of hazardous materials and hazardous exposure. It looks at fire. Given that, putting that aside, code has developed a method that is a layered approach to solving problems. So the construction type is one method, the compartmentalization is another method, the egress provisions are one, active separation systems another. So that is kind of a layered approach that code does. And there is no one common system that ties it all together. And that's where the building official or code consultants like us come in, is we can connect the dots and add value to the categories and based on that. But for a common user, as long as you understand that it is a layered system, as long as you understand that there might be pieces that don't jive in or fit tightly and seamlessly, but it is the intent to make it a continual, gradual, and layered approach. The other thing is upholstered furniture and mattresses. There are many fires that have taken place in these furniture shows because it is a storage where there's not many people attending. There's a lot of combustible materials. Accidents can happen. These are typically not even sprinklered buildings. So the code has paid attention to it. And these can generate a lot of smoke and can ignite very fast, and the fire can move fast. So that's the hazard. So upholstered furniture and mattresses, F and S1. So manufacturing and storage and retail of those need to pay attention. So the 5,000 square foot group M required sprinklers, that's the same as a restaurant. This 2,500 is the same as the woodworking operation. So you can start seeing that the numbers have connections. The code takes a number and assigns a value to it, And as you look deeper into the code, you start connecting the dots of where they come from and how the code is written. For example, one of the things I keep telling people is 10%. You'll find that number quite a bit. It's never explicitly stated, but 10% of anything is considered insignificant and therefore not a problem, is how the code looks at it. As long as it's under 10% of whatever the threshold is, the code is generally good. So why do I tell you that? So if you're writing an alternate to something, 10% is your magic number to make an argument that the code has a history of using 10% as not significant a number, right? Our occupancies, there's changes are happening our occupancies. So NFPA 13R and NFPA 13 are the two systems that the code uses. The third is 13D. So NFPA 13 is the standard NFPA 13 commercial sprinkler requirement. 13R is 13 residential. 13D is 13 domestic. So they're kind of layered system. 13 domestic is the lowest that allowed for residential buildings, 13R for for apartment complexes, and full 13 is for everybody else. There are limitations to what you can do for 13. And the code is not very explicit. It will tell you that if your sprinkler system for 903.3.3.1, you get X. And if you have sprinkler system in 903.3.3.2, you don't get it. So the 0.1 and 0.2 are the standard system and the 13R system. So if you pay attention to that, you get a lot more reduction in fire rating, travel distance increases, blah, 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 under the standard 13 system, and not get it under 13R. And very many people, if you're not used to that distinction, don't catch it. So pay attention to that. The other thing that has happened in this particular code cycle for the IBC, the base IBC, is 4 stories or fewer above grade is where you can use this sprinkler system. If you go above that, now you have to go to a standard 13 systems. So you can use, as long as 4 stories or fewer, the floor level of the highest story is 30 feet or less above the lowest level of fire department vehicle. The floor level, lowest story is 30 feet or less below the distance in the fire department measured from the grade plane. So number of stories constructed shall be measured from grade plane. So 510.2 and 10.3 is the podium construction, and the other special occupancy use construction. So this is the changes in the 13R as it affects all Group R occupancies. Oregon makes a change to it. So IBC, all Group R lumped together, NFA 13R restrictions. So R1, R2, R3, R4, all of them, right? In Oregon, we are making a special exceptions for other than Group R2. So Group R2, R1 is the transient, R2 is the permanent. By code, transient is 29 days or less, and permanent is 30 days or more. So the floor level of the highest story is 30 feet and R2, and then required fire department vehicle access. So it's adding it to required versus what is available, right? So the question that comes up here is that fire department vehicle access and required access. This question comes up so many times when you're just inches over the high rise. I get all the clients come talking to me, I'm just inches. Why is it a high rise? It's just inches above it. City of Portland, and Jody, you can jump in if you want to. City of Portland does not give you any leeway on high rise definition. Portland will give you what I call high rise light. So it will give you some relief. So code modification if you're slightly over and your other things that work well, but the high rise definition, no discussion about it. All right. But in this case, for this lowest level required fire department process is a unique thing to Oregon. I don't know if Portland has made any difference to it, but Oregon is allowing that. So roof assembly less than 45 feet. So there's additional requirements added in Oregon that makes it a little bit more relaxed for R2 occupancies.
Just to jump in real quick,
Yep.
Let's see, if you want to talk about, I'm inches over, but I have these other great things, that is definitely through the appeals process. So it's site specific. And then the other place where I feel like the appeals are more likely to be successful is if it's a small occupied roof deck. Those that are under 50 people, but they're over the high rise line, because it talks about the floor
Right.
of and all these pieces. Those are the appeals I've seen be more successful, is when it's an occupied roof deck, or if it's a sloped site and there's great fire access on 3 sides and there's one low corner that's, triggering these high rise requirements. And again, all through the appeals process.
Jody, I'm not doing another presentation without you again. Colleen, we just book her forever and ever. This is perfect. You guys are getting a wonderful presentation. This worked out even better than I thought. So mechanical parking garages are becoming more prevalent. It's more compact. It can pack more cars in a smaller space. It's just overall better for everything because you're not spending large buildings and things like that. But the flip side of that is the fire protection. Cars in general have more plastic components than they used to have. So any car fire can generate more fire, more flame, more heat, more smoke. Needs management than cars of the past. Electric cars added the added component of lithium-ion batteries. So that is becoming another one that is becoming issue. So the protection of cars in general needs to pay attention to. On top of that, when you become a mechanical store where everything is kind of enclosed and covered up, the fire department cannot get to it. So in case of a fire, the sprinklers have to do the job completely. There's no way that the manual intervention can take place. So that's the added component. So the code has paid attention to it in the IBC chapter 9, which is the sprinkler requirements. And there's additional requirements to that. And it is requiring a specially engineered automatic sprinkler system. It does not say what it is, but it is requiring that. Portland has a guide that Portland has adopted. And I haven't used one recently, but most of your MEP engineers should know it. If you don't know, we can go find it. But there is this Portland Fire Department has a guide on that. So this is when you do the enclosed parking, do pay attention to the amount of water required and the type of system that is required, that there will be a special permit and you will have to get it approved through that. Fire alarm requirements. So this is the OSSC has added these requirements for the fire alarm particular to this. So there is manual fire alarm in group R2 occupancy. The manual fire alarm work shall not be located in an area that is open to the public. And I wasn't engaged in this change, but it appears that there is concern about manual fire alarm boxes in public area for nuisance activation. And so that is probably why the reason, because the code, even when the manual boxes were required, the code given exceptions for sprinkled buildings not requiring manual boxes. Was based on the sprinkler, and especially R2 occupancy as light hazard occupancy has quick response sprinklers. So there is very early warning that is provided. Oftentimes smoke detectors are present. So that would also give a very early warning. And so the manual fire alarm box is somebody has to actually pull that down and activate it to notify of an emerging hazard. But because of other provisions, it is covered. So I'm guessing that it's probably the nuisance alarm in an open public environment versus the quick response sprinkler and the smoke detectors providing early warning as a combination why it's looked at. Similarly, visual alarms shall be provided within common public areas and not required within individual dwelling units. Again, your people are trying to sleep, and then a nuisance visual alarm can create a problem, but also visual alarms can have other effects for people with disabilities as well. So that's the reason there's an exception in the OSSC for it. Carbon monoxide detection, Oregon was ahead of the game in carbon monoxide detection. We had our own standards that we had developed. The IBC came afterwards and created that section in chapter 9 for carbon monoxide detection. Then Oregon kind of incorporated Oregon provisions within that. So the IBC, and that happened in the last code cycle. Last code cycle, carbon monoxide got kind of pulled into the base code. Oregon amendments were added, and this is just kind of a continuation of those chapters, and Oregon has made amendments to it based on that. And so one of the things that Oregon did is removed dwelling units as from sections 915 1 through 2 through 5, and then added dwelling of units as a separate piece after the fact. I don't know the rationale behind the reason for that, just pointing out that this is what Oregon has done for the alarms requirement, and pay attention to it as you go forward. Fire Command Center. So the Fire Command Center, you're primarily aware of it is in high-rise buildings where the Fire Command Center is required. The Fire Command Center in high-rise buildings was there for some time, and then it was bumped up to a bigger size as equipment got bigger and things like that. So it got bigger. Now fire command centers are getting added to large F and S occupancies. So F1, S1, moderate hazard factory and storage, over 500,000 square foot. So this is not typical building. This is very large buildings. These side of buildings would commonly be a Boeing hangar, for example, aircraft hangar, or car manufacturing facility, potentially. Could be all large F1 type of occupancies. And a large Amazon type of storage warehouse, for example, could be a large warehouse where there's very few people in a large space with a lot of combustible materials potentially. So the code is starting there. The 500,000 square foot was the threshold that it was identified. And when you have that, you need a fire command center. So the location shall be approved by the fire code official. This will, in Oregon, it will become a building code official because Oregon goes to building code. I haven't seen this particular requirement in the Oregon code, but the reason for the official is to make sure that the location ties up with the capabilities of the local fire department. So code does not mandate something that will not work at the local level. So often it leaves approved by the building official or the fire official as the provision to get that dialogue discussion. So it's actually a working solution. Separated from the rest of the building by 1 hour fire barrier, because it is a unique space that you will go in to fight an emergency fire. Therefore, in the fire situation, it needs to be protected. So 1 hour is where to start. So it has to be minimum 96 square feet, which was the old command center size before it was bumped up. Minimum dimension is 8 feet. So that's the size of the building. And fire command less than 0.15% of the total building area of the facility served, or 200 square feet area, which is minimum this. So this is the additional requirement. It happens when you have a bigger area, it gets bigger than that. I'm sure that 0.15% is 96 of 500,000 is probably how it comes together. And then the 0.7 square root of the room, or 10 feet based on the minimum size. And then as you get bigger, this becomes bigger. So that's the numbers. I haven't double checked it, but that's commonly how these evolve. So again, the requirement is coming from fire command center requirement. So typically we are used to fire command center and everything coming from a high-rise building, but now this is added to the warehouse conditions. Chapter 10, means of egress. So one of the things is happen in the code is now it's clarifying the egress path. One of the things the code has done is that the common path of travel for unoccupied mechanical students have been eliminated. So there is no common path of travel for mechanical room and penthouse room. So the commentary and the significant changes books talks about by removing the common path, it is implied that the exit access travel would apply. So that is kind of an interesting dilemma, that you don't have to meet the common path of travel, but now you have to meet the exit access travel distance. Jody, I don't know if City of Portland has looked at this, or any discussion at the state levels whether the exit access travel distance is applied, or do you know?
We haven't had discussions about that. Just looking at it and looking at the mechanical rooms and penthouses, we have not been applying egress requirements to penthouses,
Right.
On roofs at all. But we do sometimes have mechanical rooms in a basement that have, or a partially, a basement with bad ceiling height, especially in existing buildings. So we haven't had any discussions on policy with this change. I'm interested to see how it plays out.
Okay. So that's the code change that took place in the 2021 code base, and I didn't see any changes in the state amendments to it. So another thing that is happening is the boiler furnace rooms requirement, the 2 exit requirement where areas over 500 square feet and fire equipment exceeds 400 BTU. Oregon has kept that for incinerator and furnace rooms, but for boiler, Oregon makes a separate requirements. So it is identifying the combined fuel capacity is 1 million BTU per hour versus 400,000 BTU. So this requires it to be bigger than what this would have required. Still, the room area is 500, room area is 500. And there are one or more boilers with a combined fuel capacity, not individual boiler. So, and in this one, where area is 500 and any fuel fired equipment exceeds. So this one was one versus this is combined. And then where 2 exit doorways are required, one is permitted to be a fixed ladder, an alternative trade device is that. And other requirements are very similar, diagonal requirements and things like that. So the boiler rooms are separated out differently than the furnace room in this instance. And Oregon makes an even bigger distinction. I don't know where the history is based on smaller boiler, perhaps, are often used multiple boilers in that has been required, but I don't know the history of how that came about. Here's another thing. So egress from stories and occupied roofs. And IBC is allowing multi-layered terraces to go down to each other and can egress across multiple levels. Within the building, there is a requirement that if you go through, you cannot go more than one story. And this one has a little bit of a history that I wanted to share with you. One of the things that is way back when, the code allowed open exit stairs as exit stairs connecting stories, but you could not use it for exit. There were 4 stories, 5 stories, all of that, but they were not used like that. Then the code changed and allowed you to use it as exit access stairs. When that code change happened, there was a provision added under code section that thou shalt only travel 1 floor. But that was not next to the code change, so it was not very evident. So in fact, we had actually gotten a code appeal approved for a 3-story exit access stairs with draft curtain and sprinklers. Everything was done. And then Terry Whitehill came back and said, hey, Samir, this we approved, but the code doesn't allow it because there's another section we just discovered. We had to go back and reappeal it. And eventually we got it, but that wasn't. So that brought us to that attention. But what it really means, and I get that quite a bit in architecture, I'm allowed to have a 4-story exit access stair. Why can't I just do it? The reason is the argument that exit access stair can be open as long as this is enclosed and you meet your travel distance to the exit, you meet your 2 exit requirement, then everything seems good, right? Well, the issue is the exit access travel distance is based on horizontal travel. When you go down the stairs, you actually slow down when you travel. And that's what the code wants to not allow for multi-story stairs. And therefore, what it means, if you have 2 stairs, one is enclosed, one is not enclosed, and this is in this 4-story building, therefore you will need a second stair that is 3 stories to meet that provision where you're allowed to go 1 story and then go into an exit enclosure. You can go 1 story and go to an exit enclosure. So that is the prescriptive path. We have done multiple appeals allowing this building, but it is an appeal that needs to be reviewed individually and supported to do it. The rationale oftentimes that work is, one is the protection level that can be afforded with many things that are layered system that I talked about. The other thing that we look into is we do an egress analysis. So the code rationale of not allowing it is you move faster on a horizontal surface. But when you on a horizontal, we are also not as densely packed and people are more spread out and not everybody is moving at the same speed. When you on a stair, people pack the stair and move. So it's about throughput, not the speed, but the throughput. How many people you get down in how much time? And so we have often, even we have done egress analysis where in fact, there's been studies we have done in high rises in Seattle more commonly than Portland, where the building now requires a 3rd stair because of a space like a high-tech company that comes in, like a Amazon or somebody. They have multiple conference rooms and the occupant load goes over 500 and you need a 2nd stair. And we have actually demonstrated that 2 wider stairs take people down faster than 3 narrow stairs. So we have often worked on the size of the stairs, size of the doors leading to the stairs, and other things to do it. But prescriptively, the code does not allow you to have unprotected or exit access, open exit access stair protected through draft curtain sprinklers and enclosed stair as the 2 means of exit. You have to deal something with that. On the roofs, you're allowed to do that. So that's the code change. So another thing that changed with occupied roofs, and that is a provision that is evolving, is for accessible elevator. Accessible elevator is based on when it is 4 or more stories above the level of exit discharge. So if you had a 4-story building, this elevator, 5-story building, this elevator would need to be accessible. But now the code is saying if you have a 4-story building and you have an occupied roof, this needs to be accessible elevator. The issue with the accessible elevator, besides the signage and everything else, is really the emergency power. You cannot run it on the battery. So typically it means a generator, and that's the cost. The code has increased the foot candle of light that is required in exit and exit access doors from 1-foot candle to 10-foot candle. And it is not backed up on emergency power. It is normal illumination on normal power is what it is required. So that is a new addition to the code. Size of doors. The code has gone back and forth on what is the size of doors. The standard door is 36-inch. It's been there, 36-inch door, 32-inch minimum clear. That has been in the code for the longest time. The code, when you had a double door, allowed you to have smaller doors as long as the combined width was more than met the requirement of minimum required. The code allowed you to have a 5-foot door. That was under the legacy codes. Under the IBC codes, that has not been there, and the requirement has been minimum 3-foot leaf. That minimum 3-foot leaf, because if one leaf gets locked, or when you open one door, you shouldn't have to open both leaves to get in and get out, especially for accessibility, that becomes an important issue. The code has always had a 4-foot maximum swing door leaf requirement. That 4-foot maximum swing door leaf requirement has always come from the size of the door becoming big and heavy and difficult to use. So what the code is now doing is taking away that size restriction, but it still keeps the performance requirement that you start with the 30-pound load to get it moving and 15-pound to keep it moving. So it's more a performance load because the hinges and the type of doors and how you can operate and things like that have gotten better. So it's giving a little bit more leeway to the designers to design the door that will work with the code intent rather than just limiting it to the requirement of a fixed size. So we have had the locking arrangement requirements come into the code for the long time, and we have had a lot of these requirements in the code about allowing this unfortunate reality of our society that we accept mass shootings and change the codes rather than prevent mass shootings. That's the society we live it in. And now it extends to daycares. Locks and latches. This particular aspect of the code has changed quite a bit. And I won't go into all the different details, but a lot more fobs and keypads and other things are now permitted by the code because they've proven to be effective in an emergency to release the door and allow safe egress. So the key part is controlled access, but free egress is the intent of the code. As long as that is provided, that works. And then there's prescriptively different provisions have been added in for different requirements that work in, and it just kind of added more. So I1 condition 2 and I2 where clinical needs persons receiving care, egress courts through an exterior place, doors, balconies on residential, individual dwelling and sleeping, doors to balcony down exterior spaces of 200 feet. So there's lots of little things that are exceptions are provided, just coming from, it's not a hazard, prescriptively putting it in the code so you don't have to ask for permission is where it's come from. Occupancy, this is an interesting one. So the 2-story connection, in the past, you are allowed to connect any 2 stories as long as you block the 3rd one. Now the code is limiting that to 2 adjacent stories and not allowing to connect in between. So you only connect 1 and 2 and 3 and 4, but you cannot connect 1 and 3 and 2 and 5, for example. So that is something that is done. And then there's the exception for exit access diagram between occupied roofs that we talked about, which are different category where you're allowed to connect stories. Dead end corridors in I2, length of corridor extended to 30 feet. This is kind of just aligning with the NFPA 101 criteria as well. So anybody that does I2 would care about this. This is not a code change, but I want to talk about this. So when you have an exit stair comes down and you connect to an exit passageway, the common thing is if I have the stair and this all in the same rating, why do I need to have a separation here between the stair and this? One of the common argument is it's just a longer landing. It's not a passageway. And some of them are longer landings, not traditional passageway, but this, what's the whole thing? There is an exception in the code for no openings in exit passageway when interior stair exit is pressurized and there is no other opening in the exit passageway. So the pressurized is just for air balancing, right? So if this is pressurized and that is pressurized and you want to make sure that the pressurization works, the pressurization requirement supersedes the egress door requirement. So what is that reason for the door anyway? The reason for this door is typically what happens is stair comes down and there's a long passageway and other doors coming up. And in an emergency, when people come in, it is possible that the people coming into that exit passageway might go back towards the stair and there'll be a bottleneck between people going in opposite directions towards the stair and create a problem. So having that door opening, separating that makes everybody goes in the uniform direction and maintains that flow in an emergency. So that's the whole rationale behind it. So that's why when you have no other openings, then you can take it out because everybody will just going straight out. Here's something else that need to pay attention to. So exit separation and how many exits you need. So one of the things is often comes up is I have this room and I have a diagonal, I need 1/3 the separation. I don't know how many countless times I've answered the question. Can I measure it to the center of the door? Can I measure it to the inside jamb? Do I have to measure it to the inside jamb? Right now the code has clarified it up to the designer. You go to the outside jamb to outside jamb if you want to. My recommendation is stay to the center of the door because as your design evolves, doors move. And it's much harder to stop it at the end. Go conservative in your early designs at the CD levels. You can finalize it and define it. Another thing that comes up is the separation between building versus the room. And the other thing that I wanted to find out that here's the requirement, and this is not a code change in this one. So if you have required to have 2 doors and you provide 3 doors, the 3rd door, if it looks like an exit door, has to meet the requirements of an exit door. So this is something that doesn't always get followed. And if you're doing anything other than that, would have to address it because the code language prescriptively tells you that all doors have to meet that requirement. So either you're pointing it out as not an exit or something else to make sure that people don't think this is an exit. Here's the requirement about the room and the building. So this was a client came to us. The jurisdiction looked at it and they said that essentially your building separation needs to be this, and they said this is your exit separation. You don't meet the building separation. So there are 2 requirements. This is an open room with enclosed rooms along the sides. This is the complete building. So complete building, you need separation for half the diagonal. So there's exit door here, exit door here. So this are 1/3 the diagonal was sprinkler. So this door and this door provide the separation. They had a point in this room. In this room, the separation was from here to here, and the diagonal separation technically was this door was the door from the room, and this opening to the corridor, you're allowed to have an unprotected opening, but still was the exit from that. They were originally thinking that this is their room exit and that is their room exit. But by definition, this became a corridor. And by definition, because this was a corridor and it was a sprinklered building, they were allowed exemption from the opening, but still this was a corridor, this was a room. And so that was the door. So we had to work with the jurisdiction. We worked with them and they added a door here that essentially provided the separation that they needed and everything worked. But this was a problem and this was not a problem. So now I'm coming to miscellaneous others that don't fall into one category or other and combine those requirements, and we go through that. So combustible lockers are not permitted in school setup. And this is primarily because there are plastic lockers that are coming in that ignite much quicker and also have a higher smoke generated than traditional wood or steel. So wood, class C, class we can use, class C is wood. So wood is permitted, plastic is not permitted. In mass timber, as the code is getting more sophisticated about mass timber, special inspections are coming in for mass timber requirements. And so there's tables with all, and there's periodic inspection also required for sealants and adhesives. Very likely, this is not going to be enforced, but the initial special inspections will get enforced. And so these are kind of requirements that have to be done, because these are kind of a custom built elements and need need these revisions, because to make sure it's getting built that is what intended to be. Overall, the building code has increased the special inspection chapter than it has in the last couple of cycles. Concealed spaces, type 4 heavy timber concealed spaces is now getting relief. This provision, it follows what is permitted in a type 4 ABC construction. So type 4 were very prevalent in the early 20th century, mid 20th, even up to mid 20th century. After that, it went away because of the concealed space requirements. Type 4 evolved out of the large Chicago fires and other fires, because type 4 requires the exterior walls to be non-combustible, and interior wood is heavy timber. And by doing that, it prevents the fire from jumping from one to another. So it was looked at as a very good system, except it allows the fire to smolder and spread across. Early 20th century, the sprinklers were not very good, and the sprinklers have evolved and performed far better. Even though the basic concept of the sprinkler has not changed a lot, the performance of sprinklers have changed quite a bit and have become far more effective than the early sprinklers were. And so some of that is now coming into it. The lessons we have learned through the mass timber are coming into it. And overall, the concealed space requirement is following the type A4B. So now you can have a type 4 heavy timber building and put ceilings and things like that, and actually do other things that you were not permitted before. So water supply requirement for during construction is a new element that is coming in chapter 33 of the fire code. And so these are requirements coming for type 4. Sorry, chapter 30 of the building code versus chapter 14 of the fire code. And so this is requirements for vertical construction type 3, 4, and 5. So prior to commencement, type 4 buildings, the fire flow requirement shall be provided by fire hydrants. Fire separation of 30 feet from property line, 500 gallons per minute, up to 30 to 60 feet, 500 gallons or 50% of the fire flow. So these are requirements, because what is become an issue is there is more wood construction, especially with now type 3 ABC becoming more prevalent, type 4 ABC coming in, and to protect during construction where it's the most susceptible for fire.
And I could be wrong on this, but I believe this section is removed for Oregon because of BCD's insistence that the building code has nothing to do with
Fire fighting. Okay.
That's all fire code. Our safeguards during construction are like OSHA related or fire. So again, I could be incorrect on that, but that's my.
So please do double check, and I haven't checked that for deletion. I'll double check and we can follow up later on, but makes sense from what I know of how Oregon approaches building and fire. Intermodal shipping containers. So shipping containers, there's all kinds of people in boutique construction companies, developers, architects who are enamored by shipping containers, using this for buildings. And containers are used boxes. So the code has always been reluctant to use used material in new construction. So that was the hurdle. And then it was not tested as a building assembly. So that was the other hurdle. But it has become prevalent around that now the code is approaching in understanding it. There are exceptions for stationary storage battery arrays listed in equipment, because these type of containers are used for like mechanical systems, battery systems, and other things that are shipped as packaged units that sit outside as exterior units. And so the question is whether that's a building, whether that's an equipment comes into play, depends on whether people go inside and things like that. We have dealt with that on multiple industrial sites, but that is accepted, except exceptions are provided in this. And then the code has created a whole chapter requirements for these things. I mean, some of these things are really evolving into beautiful spaces and are creatively used. They are look great, work great, but there was no code requirement. So now there is a whole list of code requirements that are applied to them. Bathrooms in general, there's lots of requirements for bathrooms. In Portland in particular and in Oregon, gender neutral bathrooms is an important consideration. So the code doesn't have gender neutral per se. Code is trying to start addressing gender neutral and saying the multiple user facility shall be designed to serve all genders. The minimum fixture can be calculated 100%. So if you have serving, so for example, if you're serving a non-gender specific or gender neutral everywhere, then your count should satisfy the 100% of the population. And if it is if there is different requirement for men and women, then you have to meet the most restrictive standard. And I haven't actually had a condition where we have tested it, but that's how I would interpret it in gender neutral. But family rooms where you can have an individual bathroom that can be used by a man or a woman, those can be added as independent facilities, and you can count this as men or women to meet the criteria requirement. Gender neutral bathrooms are where there's combined bathrooms where anybody can go in, and those have very unique conditions because not everybody might be comfortable going in a gender neutral bathroom. And so because they're not comfortable, then the bathroom may not be available because of their mental perspective of how a bathroom ought to be and things like that. So the code is trying to be aware of that and address that in the requirements, but separate facilities is a different facility. Oregon does amend this and we allow where employees do not exceed 30 versus where the standard IBC is 15. B occupant employee customer is 50 or more, and that changed from used to be that we used to have M occupancy load of 100 or less was a separate category. Now it's just B occupancy. Oregon used to amend that to 50 or less, is now in the code, but separate facilities required operational needs on approved configurations gives you the basis to make an argument for M or F or something else to go through and do that. Solar energy systems.
One more thing on that one, Samir, that Oregon is adding that I think everybody's going to like is amenity spaces is new footnote F. Amenity spaces, leasing office storage spaces accessed only by occupants of R2 dwelling units and their guests. Building leasing agents and their staff or building maintenance personnel can be provided a single user toilet room for up to the first 100 occupants. So this is that non-simultaneous use with apartment buildings where we've had to have an appeal each time. Right. There's going to be a footnote F that covers at least up to the first 100 occupants, a single user restroom.
Very good. That was a common appeal that people would come to us and ask for help, and I'm sure many have gone directly to you as well. So that's good to hear. Solar systems. It's a new category in Chapter 31 has solar systems. The Fire Code Chapter 12 has solar systems as well, and that is regulated. The thing is, there is access required at the top of the solar systems or around the solar systems. This was a particular solar system that was done in Hillsborough in a school district, and there was a room underneath was a battery. Because this was a covered space, they were using it as an e-occupancy open classroom every once in a while. It became a building. And so we were trying to figure out how to address it. The intent in having access about this is primarily because people, if they were roof mounted equipment, then fire department had to have access to go around it. But as we discussed with the Hillsborough Fire Department, one of their concerns in this is that these tend to still have fire problems. So the fire starts on this because of the short or fuse or something like that, and that happens. And how they typically fight it is they have a fire blanket that they throw on top of this. So the fire department, the code requirement is on 3 sides, and the fire department said, really, we need it only on the top side, so we can walk up there and then roll a blanket down, and that's how we'll control it. So understanding where that is coming from and what that means is important. But we talked about energy storage systems and solar energy systems as part of that chapter as well. So guards at roof, it's a common thing, but it's a common miss that when you have less than 10 feet, you have to provide guardrails around it or provide fall protection. This is not a change in this code, but it is been in the code for a while. And that's all I have for you today. And as you know, Code Unlimited merged with Jensen Hughes, so we are a global code consulting firm with a lot of capability across the board. And typically I'll take questions now, but let's pull it all together, give Jody time to do her presentation, and we'll take combined questions afterwards. So with that, let me stop sharing. And Jody, do you want to go right away? Do you want to take a few minutes break and come in and start it? What's your thinking? You're on mute, sorry.
Can we do the 5-minute break again and then
Okay.
come back?
Sounds good. So it's 11:12 right now, just about 11:20 we come back.
Sounds perfect.
All right, let's come back at 11:20. So, Elisa, your question about kind of gender neutral. So, Jody, City of Portland is more progressive than other jurisdictions about gender neutral. So, Portland has guidelines about gender neutral. How does that extend to rest of Oregon? Other officials have looked at this favorably, or do you know?
The main thing that Portland has is that code guide about gender neutral restrooms and how you can start counting them, and some guidelines around the requirements. The rest of Oregon's welcome to look at our code guides, and a lot of jurisdictions do use the Portland code guides, but they aren't required to. So I would say if you have a project in another jurisdiction where you have something you're trying to do, using a Portland code guide as support with the local jurisdiction could be useful. But I would also recognize that there are some opinions about Portland out there in the rest of Oregon sometimes you should be aware of, and putting Portland's name on it doesn't always help.
So, Alyssa, does that answer your question?
I think so. Generally, there was a comment about discomfort potentially with a shared user gender neutral restroom. I was just wondering if the discomfort came from sharing lavatories after using a single user toilet compartment.
No, it's concurrent use is the concern, not as an individual single user.
So theoretically, if you wanted to have all unisex restrooms, would you be allowed to meet your minimum men's and women's counts in a facility, or is a shared facility still required under the current code?
Go ahead, Judy. I think that's been used. Yeah.
Yeah, you can definitely use a number, like all single user restrooms. The Portland Code Guide was trying to address and open up the option to use toilet compartments instead of full walls. And it talks about, full to the bottom and some things about ventilation. And so it was really trying to address, everybody realizes that 4 walls makes a single user restroom. We're all good there. But when do you get to single user when you're in the world of toilet compartment partitions?
Okay, thank you.
Yeah.
All right. Judy, we're at 11:20. You want to take over?
Yeah, definitely. So, and let me share my screen. All right. So I was, like I said, excited to be able to come and share and talk about some of these different pieces we're putting into place. Too far. A lot of the energy code changes have been off cycle the last few years, which has made them especially confusing. But what BCD actually has put together a web page about why they're making the changes and the processes that they're trying to work toward. There's been Executive Order 2004 that was signed, I think, March 2020, is following up on another executive order from 2017. And both of those are putting directives from the state legislature onto the state building department about upping the energy codes faster than the national code cycle is going. The latest one, this Executive Order 2004 requires that there's a 60% reduction in new building annual site consumption by 2030 from where we were in 2006. And in order to get there, they've been, like I said, making energy code changes off cycle of the building code changes and trying to keep up with the residential building code and the commercial building code, which are also off cycle from each other. So you probably, well, we as the jurisdictions, we've been having trouble keeping track of, which permit came under which energy code. And then even within that, there's been options. So October 2019 is when ASHRAE 90.1 2016 was the standard, but there was still an option to use the I codes, the IECC, which is what we've been using for forever as a base model code. And then in October of 2021, ASHRAE 90.1 2019 edition was adopted, and it's mandatory. You don't get to use the I codes anymore. Both of those are amended by Oregon with the 2021 OEESC, the Oregon Energy Efficiency Specialty Code, amends, it pulls out, as it does usually, the chapter 1, puts in its own chapter 1, and then also has a couple of other amendments. So that's the way those two codes work together. A little bit similar to chapter 11 scoping and the A117 accessibility requirements. It's a little bit like that, but not exactly. It's a lot closer to what Samir was talking about with the chapter 34 and the IEBC, where it's taken this other code and amends different pieces. I was going to show y'all City of Portland for our internal use. We go ahead and take the ASHRAE code and gray out the portions that were removed by the 2021 OEESC so that we don't accidentally enforce those. And we make the changes and additions so that we're looking at the code and not getting confused when we're making calls. Let's see. So where we are now, we do think that the codes are going to continue to increase in the requirements. They're going to keep trying to go toward that 60% reduction. There are certain distance about where they think they should be, but kind of all the easy things have been done. And so the next energy reduction requirements are kind of going to be harder and harder is how we expect things to go. So what we've got right now to submit with your permit, we need the comm check still. Instead of now we're using, when you do your comm check, make sure you're picking ASHRAE 90.1 2019 edition. There are also organ specific forms. The comm check supplement has the extra pieces that Oregon has either added or removed. So for example, Oregon says that instead of, I don't know, 75% high efficacy lamps, if you're in a dwelling unit, you need 100% of your lamps to be 100% of your lamps to be high efficacy. So there's these tiny changes, and that CommCheck supplement covers those. The 2021 OEESC compliance form is, again, it's a state required form that you're supposed to submit with permit. And it is basically a summary document. I chose prescriptive or I chose performance. And then also there's this zero code calculator, which is a separate program. It doesn't take a long time, but it's trying to, let's see, it's trying to say what the estimated energy usage of your building is, what you could put of PV on it, but if you didn't put PV on it, what you would have to use for offsite. It actually doesn't have any requirements for the buildings to meet. It's more about, here's this building that's being built in Oregon, here's the energy we think it's going to use, and here's what it could have done with energy efficient power sources. At least that's my interpretation of what this document does. Here's some examples of here's the compliance form. It's got the link to it, and then the energy calculator zero code. We've had some folks, internal and external, be kind of nervous about this zero code calculator report. but it's really about a documentation piece that doesn't take a huge amount of time, and the numbers that are in that calculator then get put into the energy compliance form. Oh, and I see there's a couple of chats. I'm gonna wait to the end because my slide deck is much shorter than Samir's, and I'll just answer everything at the end. So those are the pieces we need to come in with the plan review. During plan review, we're going to be looking and giving you a new document similar to like a special inspection form for fireproofing, deferred submittals, or special inspections on, you know, all the structural pieces. And it's this energy efficiency compliance acknowledgement form. It's letting us know whether you're going to do the blower door test at the end for the air barrier design, or if you're doing the independent third-party review, which reviews the design as put into the documents, and it does installation special inspections or third-party inspections. So that's one of the pieces. That's this part B in there. And then the other piece is you're acknowledging that at the end, the project will need to give us the commissioning compliance checklist, which I'll show you in a second. One other point of note, just in the way that Portland does our permitting, the electrical trade permit covers the details of all the electrical systems. There are now some energy requirements in electrical that are too complex to try to put into the CO permit. So we're reviewing those under the ET permit, the electrical trade permit. So that includes, let's see, like the lighting controls is pretty intensive. There's meter monitoring, energy meter monitoring, and the way that you set up your meters. There's EV capacity that's currently only in the building code, but for Portland is going to eventually be increased probably under the zoning code. The details of all of those systems are going to be reviewed in the electrical trade permit, but we want to see in the CO permit documents that you know those are coming, that you're acknowledging, like, so if you're showing a one-line diagram for in your electrical drawings, it needs to be showing that energy monitoring, the meter, all the different types of meters, but we aren't actually going to be reviewing that under that permit. And then at the end of construction, we will be asking for this blower door results reporting form, again, a state form that we've been handed that we need to be asking for. And it is kind of the wrap up. That's how you satisfy that energy efficiency compliance form that I was talking about during plan review. So you'll hand in this, or your contractor will hand in this blower door reports results reporting form. It says, here's the third party person who did it, and here's their signature, or here's my blower door test and how we passed it. There is some discussion right now about whether or not to have a final summary report submitted from the electrical designer, similar to a final summary report that may, or like a structural observation report where the folks who designed the lighting controls lighting controls and the rest of the electrical pieces will be, they have to do commissioning anyway, but we're trying to decide whether or not we want somebody to hand in that report or not, which brings me to this commissioning compliance checklist. This is a document that covers the extensive commissioning and fine end of project requirements that are in ASHRAE. We are not asking for all of those different commissioning reports like we would for maybe a smoke control final testing report. We do ask for that, but in this energy world, we're asking for somebody to sign this and say, yes, all the commissioning was done according to these different systems. And I believe it has the certified commissioning professional listed. It might be different ones for different systems, but this document is required before you can get your final. And this is my last little section, but when I say we need the comm checks, there are some additional options now. So the standard approach would be just like I said. So for your envelope, you've got the comm check building envelope report, and there's the supplement form that has those different little pieces that are a slight bit different than the regular comm check. Or there's the simplified building method envelope, a document that BCD came up with, and fill that one out instead of the comm check. Really, it's intended for smaller, simpler buildings. I think you'll have to look at it and decide if it is easier to use or not for you and your project. And there's a simplified form for lighting as well as mechanical. The odd thing about lighting is that you also still need the lighting comm check, even if it says it fails. The way that the simplified building method lighting form indicates you still need to hand that in. I can only say that we are just following what the state has handed us in some of these, well, in all of these different forms and pieces. It's very form heavy process. Here's the mechanical. And then here's some additional energy code resources. The first one is where we sent out the update talking about that commissioning compliance checklist and the air barrier requirements. I think there's also some language on there on some notes that we would like to see on the code summary page that acknowledges the requirements of both of those things. And then the rest of these are, Oregon has put together a great energy code compliance webpage. Because this is so complicated, it's got all the different forms linked on it. And then a couple of other resources on just getting used to ASHRAE, really. So that is what I got. Are there any,
So take your questions, Jody, that came up on the chat.
okay, let's see. Is comm check required if using prescriptive path for the envelope? Yes, it is, because there's more in there than just the, there's more things to fill out other than just the different components of the envelope. Like there's a bunch of check marks about, yes, I did the right thing with my labeling of the windows or different things like that. So yes, we are still asking for it. Vestibules, are these mandatory? Air curtains in lieu. So I believe air curtains are allowed as an alternate, and that's one of the additions that Oregon added as an alternate. I don't know the code reference off the top of my head. And the vestibules also are not mandatory, sometimes with the size of the space, I believe. But again, this level of detail, I'd have to look and get back. Can CommCheck software be used as a performance model? I'm not sure the answer to that question because I'm not familiar enough with the different options in CommCheck. I do know that CommCheck simplified trade-off, when you're putting those different values in the areas, it's kind of building an energy model back behind the scenes and handing you, yes, it meets, or no, it doesn't. So if that's what you mean by performance model, then it's a little sort of performance model light is what I would call it.
Can you hear me?
Yeah.
Oh, great. So yeah, we were just doing this project in Wilsonville where these questions came up, and the use of CommCheck as a performance model, because we are doing the chapter 5, which is the envelope trade-off method. So we just wanted to make sure that the CommCheck would suffice as the performance model and not the prescriptive, because obviously you need CommCheck for both. So if you're saying, if you're checking the performance model, do you need anything above the CommCheck, or is the CommCheck enough? That was our like internal questions as well as, yeah.
So let's see. I want to be accurate, but my understanding of ASHRAE is that there's prescriptive, there's simplified, there's simplified trade-off. And there's a whole nother section about performance modeling that also involves the
Whole
way,
building model.
right, the whole building model. So if that's what you're talking about, whole building model, then I don't think that ComCheck software will be sufficient. But I recommend, if you have a question specific to a project, letting us know, and we can get one of the mechanical reviewers to look into it.
Sure. Yeah. Thanks.
Can you also talk about natural ventilation requirement for ERVs? I cannot talk to that right this minute.
All right. Just trying my luck here.
Yeah, I do know in residential construction, like 1 and 2 family homes, they've got the whole building balanced ventilation system that I feel like undermines the tight envelope, but it's because of the tight envelope. So, but I don't, in terms of how that relates to commercial construction, again, I'd have to defer to our mechanical reviewers.
Thank you.
And I had one other question that I think was just to me, about which forms are for new construction. So and I had that on the thing. We are requiring all of these for new construction only. There would be a case where you might need to submit one or another, like a lighting one, if you're doing an alteration, or if you're doing an addition. Of course, we're going to need some sort of a form. But in terms of the blower door test, that's not for existing construction or for additions. And in terms of the commissioning compliance checklist, although I think it's probably required by ASHRAE, we're not enforcing that checklist on existing buildings unless you're doing something like, you know, I've got a warehouse, I'm scraping the inside, and now it's an apartment building. In that case, we would see that as a whole new envelope. So are there any other questions for me or for Samir? How about that?
Yeah, I'm open to questions. Colleen, do you have anything that you want to finish up if people start leaving? No, anything you want to announce for AI? If not, we'll just go straight to questions. All right.
I did want to make a plug for the building official determinations that are on the City of Portland's website. A lot of you are probably familiar with our code guides. Those are the ones that are more robust, multiple pages, cover large sorts of topics, but we have another category for the past 3 years. We've been slowly adding to it, which are the building official determinations. Sometimes those are just an interpretation, and sometimes those are actually kind of like a tiny code guide that gives something away, but it's not a big developed topic. It's just a tiny little piece. So just want to let you know those are there, and a good resource for figuring out what does Portland think about X topic.
So question 1, David, are you available for review of projects for conformance during the design and documentation process? So what's the pathway process, Jody, for getting an early review of energy systems?
I mean, the only processes we have for early review of anything in terms of my work group, which is life safety, mechanical, is the preliminary life safety reviews. So we can have mechanical look at particular questions or that you have, but well, I guess we have one other path, which is in the major project groups where we actually do early reviews, but there's a maximum of 5 projects in Portland per year that are in that program. And there's an intensive extra cost and a whole bunch of other things that go along with that, but you can get early reviews during that. The rest of it is more about specific questions, but the preliminary life safety reviews do cover mechanical, structural, fire, other groups if you want them to be included, or maybe instead of the life safety reviewer. And one of the best benefits about that is the person doing the preliminary meeting is usually the person who's going to be reviewing your project. So instead of just calling Portland, getting whoever, and then that person not remembering or knowing what the other person said 6 months later, you've got more continuity.
And I think there was one point Portland had, you could just call and ask for 1 hour of time, or that is just gone away now. It is all preliminary FLS, correct?
Well, we have the 15-minute appointments,
Okay.
and those are free and they're online, and we have people assigned to shifts. So somebody has the first 4 hours a day, somebody else has the second 4 hours a day. They don't prepare for those ahead of time. That's similar to the question slips we used to have in the DSC, only it's, I would say, probably easier for folks to access because you don't have to go down and park or anything like that. You can, you know what time it is, all of that. So we have those, and then we also have, we call them internally, we call them trackets, but when you do a phone call, the front desk routes that to the correct group, sets up a question, an email that we look at. And again, we have somebody just assigned to shifts and they go through whatever questions came in that day and call each person up. There's not the same level of continuity that the preliminary life safety meeting has, but it's very easy and it's all free.
Right. The next question was, energy storage system requirement applied to battery backup systems? Technically, yes, but most of those would not require it because there's thresholds and you'll probably fall under the thresholds for battery backup systems. But yes, technically it's under that. So OSSA enforcing 2009 ANSI or a newer version. Actually, Joshua from our office is going to do an ADA code session. So that will be a great place to learn all that. But Jody, do you want to touch on that?
They switched it to the 2017. So starting in April 2017 is the required standard. And that matches what they're matching what the model code is doing. So it actually took the model code that long to adopt the 2017. So it's the 2021 IBC adopted the 2017. Because there's that new larger turning circle. So everybody was really holding that off for as long as possible. But yeah, it's here.
Is that in April or will that be January?
So April is the mandatory date. They pushed it out, like Samir said, from normally we would do January, but April for all the codes except for mechanical is mandatory in January.
Gotcha. Thank you.
So then I had the same question. Your edited ASHA document, is it available for everybody else?
Wouldn't that be great? No, we are not authorized to do that. On the plus side though, we used to do the same thing with the existing building code, the IEBC, and put all those chapter 34 edits into it. This year's 2022 OSSC now has the integrated chapter 34 again. So we don't have to keep track of 2 books and do that stuff. It's all in chapter 34, which is great. I would love for them to do a similar thing with the 2021 OEESC and actually pull the ASHRAE info in. But one of the problems is the ASHRAE setup is so different, like the way the code logic works. I think that's a much bigger ask of BCD.
Okay. All right. Those were the questions that were listed. Anybody wants to write any more questions or raise a hand and ask questions? We're still here.
Question. I don't know if you can hear me. I had a question. Can a mothering room serve as a assisted toilet room?
I haven't come across that one. So the question really comes to the performance of the mothering room for what the company wants to do, because you want that space to be a space that will serve the purpose. But if you don't have the perfect environment, and it is a dedicated bathroom with perhaps an enhanced dedicated bathroom for the building code purposes, would that work? I don't see why not.
Yeah, I understand a mothering room must be separate from a toilet room, period. Is that correct?
I have not come across that. Is there a requirement, Jody, for mothering room to be a separate than a bathroom? And is it a required requirement?
I've heard it the opposite direction where you cannot, and this I feel it's not in building code that I know of. It's in like maybe like OSHA laws or something like that, where it says if you need to provide this lactation room, it cannot just be a toilet room stall. I mean, that's the intent behind it, I believe, but this is outside my realm of expertise.
All right. Anybody else? Going once?
I had a question in the energy code deal, the supplemental form that you fill out, and you're supposed to talk about zero energy. If you have a kitchen and you don't know exactly what the electricity draw is going to be, how do you answer the question in terms of the amount of energy you suspect the building will use?
So you actually are not going to be filling out that piece of it. You're going to say, I have a 5-story building with this much square footage and it's this use. And they spit out a number of how much anticipated energy use you'll have. It's much rougher calculation than specific to the particular equipment you've picked or anything like that. It's a very rough estimate.
Cool. Thanks, Kurt. Maybe you should join us sometime. You've been away from this for a while. Kurt Wilson just thanked us for doing a good job, Jody. And I know that Kurt has been doing it for a while, for many years, and I took over from him when I did.
It's been great. I'm glad we're doing it, and it's important with the code coming up. So appreciate the time.
Yeah, and I will take this opportunity, Jody. This has been an honor and just great to do it with you, tag teaming. We should do it more often. We tried to get Terry to do it. He was just too busy, and he has a wealth of knowledge. So do you. I really appreciate you coming, and it worked out really great. We should continue doing something similar with others from the city as well, but especially you and me. I would love to do it again.
I think that the city also has an interest in getting all of this information out and hearing back. Actually, if when y'all start using these forms and you have some particular issue, let me know. My email address is jody.orison@portlandoregon.gov. But we are, we make these things up a little bit in a vacuum. We aren't totally sure how they're going to work out. We have some individual cases where sometimes there are problems, but sometimes maybe they're not problems. And we would love to hear both sides or just some feedback, because some of these were, like I said, we're developing this and we're doing our best. And sometimes we've done something we think is clear and easy and we've missed the mark.
And one of the things, Jody, we talked about as we were developing it, that you don't necessarily have a time allocated to develop a presentation like that. And we have many presentations developed. I think just having you or somebody like you participate in the Q&A afterwards with us presenting would not be a bad way of engaging the city more actively. So we don't put a burden on you, but get the benefit of the resource to everybody. Cool.
I also think it would be a good idea for one of us or some of us to reach out to Mark Heiser with BCD
Energy.
and get his input on some of the forms and the requirements I think are going to be a little bit baffling for all of us, especially with the various jurisdictions. I've been really appreciate, Jody, hearing the perspective of the city of Portland and all the other jurisdictions we're working in and how they're going to handle this. So it would be great to get some thoughts from Mark on that as well.
Actually, Mark has done presentations too. If you ask him to do a presentation, his role is a little different in the past, and he might actually have a presentation that he might come give to us. We should talk to him.
To piggyback on that, they are going to do code change classes, but they're on YouTube now. So you don't have to go and be in a cold auditorium for a day in order to keep up your organ inspector certificate. Like it's not limited the way it used to be. They're just online. So they're going to be putting those out, I believe, around January, and those cover energy as well as the 2022 OSSC. I would say for my group, I love the new format, partly because then we can watch it again when we missed something the first time. You come back to it where it wasn't applicable to a project you had, and now it is. But I really enjoy that resource.
Cool.
That's great.
All right. I think we've answered all the questions that came up. We're close to the noon hour, and anybody else wants to jump in?
Well, thank you so much, Samir and Jody, for this. It's always appreciated.
Thank you very much. You're free to go, and appreciate the AIA for putting this together, and Jody for joining me. It's been wonderful.
Thank you all. It's been great.
Thanks.